Hello, welcome, and good afternoon. This is the deep dive. More of my windows under control here. There we go. All right, there we are. Yes, welcome. Happy Friday. This is the deep dive, like I said, for anyone who is new and doesn't know. My name is Tim. I go by Foamy Guy on GitHub and Discord. And this is a stream where we work on CircuitPython stuff. If you are in fact new and don't know what CircuitPython is, you can learn more about it at the main website for the project, circuitpython.org. This is basically a version of Python that runs on tiny computers called microcontrollers. When you choose to use CircuitPython with these devices, typically the way it works is you plug it into your computer with a USB cable. It shows up like a thumb drive, and then you can edit a Python code file on that thumb drive. And when you save it, the Python code will actually get executed by the microcontroller. And then your code can interact with whatever other little electronic things that you connect up with your microcontroller. Some devices are very general by nature. They just have lots of available pins that you can hook up whatever you want to. Other devices are more fine-tuned and for specific purposes with sets of built-in peripherals and hardware that are meant for specific things. So that is a very, very, very high-level view of what CircuitPython is. As always, we will say thanks to Adafruit. Adafruit is a hardware and software company based out of New York. They are the ones who make CircuitPython possible by paying a team of folks, including myself, as well as Scott, the one who started this podcast, to work on the CircuitPython project. It's an open source project, so all the code and everything is published under open source licenses, but Adafruit funds the development by paying a team of developers to work on it. And libraries and infrastructure and all sorts of stuff surrounding the project. So huge thanks to them. If you want to help support CircuitPython, one of the easiest ways to do it is by purchasing hardware from them at their shop, adafruit.com. Today, I am jumping into SPI register land, working on the BMP5XX. We worked on this driver last week. What is up, Yano? Hope you've had a good. Hope your week's been a good one. Yeah, it has been. Been a pretty good week for me. Thanks. It's been. I will say one nice thing is that around here the heat has seemingly finally broken for the summer. So we've been having some cooler days, and it's been nice to get out and walk and have it not be scorching hot. So last week on the deep dive and on my stream, I worked on the driver, CircuitPython driver for the BMP5XX. It supports the 580, the 581, and the 585. I've got them all sort of here on my desk for testing, but they are all essentially the same. They behave the same, I should say. The differences are that the 581 is more precise. It's a little bit more expensive than the 580, but it has a more precise reading for pressure, and then I believe temperature maybe too, but I'm not certain on that. And then altitude, which is derived from pressure, also improves due to the improved accuracy in the pressure. The BMP585 is essentially the same as the 580, but it has this little sort of can cylinder thing where you can hook up a tube if you want to run it to a specific sort of vessel or something. But software-wise, they are all the same. The same driver works for all of them, and there's no need to really change the driver for any of them. So we do have those. And last week what we worked on was the I2C driver. But these chips do also support SPI. There's a chip select pin, which is labeled on this one. It's easiest to see here. Chip select CS, it's a little small there, but that second to last pin is chip select. And then there's SDO, which is part of the SPI bus, and there's SCL and SDA, which are traditionally I2C pins, right? But those are also used as part of the SPI bus for these particular sensors. And so I'm trying to see if I can get the SPI driver working. And I'm trying to use this register SPI library that we created a while back, but it's never been sort of like officially released. I mean, there's a release for it, but it's never, I don't believe it's in the bundle, and it doesn't get updated. And I don't know that it works. There's no example for instance, or there is, but it's empty. So it's not like a completed, released, ready to go thing, but it does exist. We started at one point using some code that came from a PR on the other register library, the normal register library, which is for I2C. But for various reasons, you go to the history if you wanted to read the old PR there. For various reasons, we decided at the time that it would be better to have it in its own library, and that's where this landed here. But it has never really gotten past the point of just kind of existing but not really working or being released officially yet. And it would be cool if we can get this working, because then we could potentially refactor the BMP5XX driver a little bit to have both I2C and SPI implementations. And ideally, fingers crossed, I don't know if we're going to get this lucky or not, but ideally the way that I would like it to work is kind of have register SPI be sort of a mostly drop-in replacement for SPI, for register, so that the code for I2C versus SPI is basically just choosing where to import, like which register to import and use, and the rest of the code hopefully can just be the same. I don't know if that's actually gonna work out or not, but that's my hope. But before we can even worry about anything to do with how the library is factored or anything like that, we have to be able to get the SPI to work, which it's currently not working. The first thing it tries to do is reset the device and then read the chip ID and make sure that it's good, and it's not good. Although I will also say the error message is wrong because it's saying that it's 0 when it's actually not. And I have a guess as to why this is. So that's where we will start. What is up also to Mark Gambler? Nice to see you, my friend, over on the Discord there. Yeah, we've gotten a break from the summer heat here as well. Nice. Yeah. Been great. So for right now, I just have a separate copy of BMP5X SPI. Eventually, like I was saying, I would try to integrate this somehow and use like subclass, superclass or something, but I wanted to just try to get it working before anything else. And it's not quite working yet. And I suspect the reason that it's not working, to finish the intro here, I suspect the reason that it's not working, I have the data sheet for the BMP581 right here, but again, they all work the same. Under the SPI section, SPI write operation, it's expecting us to send 7 bytes of an address, A0 through A6. Those are bytes of the address, or bits, excuse me, bits of the address, 7 bits. And then the most significant bit of that first byte, those 8 bits, is W, which they're calling the write command. And if we scroll down a little bit for reading, it's basically the same thing, 7 bits of an address. The most significant bit is R, for the read command. As far as I can tell, nowhere in this datasheet does it say what's read and what's write, but luckily it's a single bit. There's only 2 options, and it's not currently working, so that suggests that what it's doing now is wrong. I did actually find, though, as I was reading back through this issue here on Register SPI, Jerry Needell, community member, noted this passage that Jerry does a lot of work, on the RFM radios. And on those, the most significant bit is again used to signify a read-write flag. And on those RFMs, it uses 1 for write and it uses 0 for read. But Jerry goes on to say on the BMP280, is not what we're working on, but is the same family. It's also Bosch. I would assume it's probably the same as what we have. It uses 0 for write and 1 for read. And so right now, when we are trying to read a register, like the chip ID register, for instance, it is an instance of RW bits. I have most of this stuff commented out because I was trying to really pare down to just the specific issue. Okay, so it's an RO bits. RO bits, which just extends RW bits but overwrites set, so you can't use it. And RO bits, what happens when you get an RO bits is right here. I've added some print statements here as I was trying to figure out what was going on with this. And what I have found is that our buffer does contain the address. I printed out the buffer that we are writing. It contains the address of 7 bits, but there's no 8th bit. There's no most significant bit, which would be, I assume, because it's a 0, and the leading 0 just gets taken off when it gets printed. So I assume right now that when we do this SPI write transaction, which is inside of the get, when we're trying to get the chip ID, I assume that we are writing a 0 as the most significant bit of the address. And then I also assume, based on what Jerry said, that a 0 is used for write, which in our case is wrong. And that is leading us to get a value that's not real. We're not actually getting probably anything from the register. We're just getting like the wrong value. And then we do have code somewhere in here which is basically validating the address is correct and not actually correct because we're not actually reading it. So here this validation fails. I changed this since it does call it 0, which is not actually true. 1 second, I'll be right back. Okay. So we are actually performing a write before the read. We are doing a command soft reset, and then we are trying to get the chip ID. So there's actually perhaps some chance that this write is actually working. We are resetting the device successfully, but then our read that comes after it fails, because when we write, we would actually be having the same problem. But as we saw in the datasheet, W is the first bit there, and then as we saw what Jerry said, 0 on the BMP280, 0 was for writing, and we think we have a 0. So maybe writing is working, but reading is not. In order to test this, I am going to kludge it together by just basically changing this here. Eventually, we're going to want this to be sort of configurable. So I think what we'll need is an argument that's like, I don't know exactly. First bit polarity, most significant bit polarity. Part of the trickiness, I think, is it, like Jerry said, it doesn't seem to be a standard. So some devices behave this way. Some use the other polarity. Theoretically, some don't even have this at all. I don't know if there are any 8-bit addresses out there. That would be an interesting thing to know. But to see if this is even our problem, I am just going to shift a 0, or a 1, I mean, into the most significant bit here. But I also don't do a lot of bit math calculation stuff too frequently. I'm actually going to ask friendly bot friend Python shift given bit value into the, I think it'll figure this out, into the MSB of a 8. I don't know if we'll really need the whole function, but it should have the code we need. Should have told it not to explain. Wait, what's this? So our byte is the first one in buffer. 0th index. That is then shifted. This would be, well, we could put it back in buffer, honestly. Then bit value, I'm gonna hard code to 1 right now because we're inside the get. We know for this driver, or we suspect at least, that 1 is the read command. Okay. That, I think, is better. It failed for a different reason, but that's probably because I commented out almost everything. And I think this might actually be correct, right? So it did not fail saying that the chip ID was wrong, which means the chip ID was not wrong, I don't think. Shift doesn't seem to me to be the correct thing. You just want to do address and. Yeah, that makes address or instead of and. Yeah. So, yeah, let me. So if we had, so I know we actually have the address of 47? Well, right, we're on SPI. We don't have an address. Chip ID, though. Chip ID is what I'm after. The I2C address is 47. The chip ID is one of these. So what's that? So bin of 0x50 is... Okay, that is what we got. So that's good. What is... so it's the register address. Right. So this is the register address, which in our case... The chip ID register is this, which is just 1. So bin 0x1 bitwise or yeah. Okay. That works here. One did seem to work, but I do think that's probably simpler. Shifting. Or whatever we actually did. Where'd the read go? Always. So, well, okay, so one problem with that is when we want to set it to 0, right? Because this, I can't put it back. I can put it back the other way. Okay, right, because... Wait. Well, Right. Okay, but what we can't do is after we have put it in the buffer. So if we like actually had a buffer, I'm gonna make a buffer that's just a single value instead of a list. This one is an array or something, but a single value will be simpler and we'll do the same thing. So if we have 0x1, which is the register address, if we bitwise OR it 3, 4, then it is correct. But now if I want to get it back, if I want to switch it, because we would need to switch it whenever we wanted to write. So if I wanted to switch it, we now have the problem of if I do bitwise OR with 0, it's wrong. Whereas this way makes that work still. Makes it so that I can always do this operation on buffer 0 and be able to flip it either way. And all ones. Does that work? So as I said before, I don't do a lot with bit stuff. I have a lot of practice. So with, is that 7 or 8? Is that going to work for both ways, or is that only going to work for back the other way? 2, 3, 4. That is so hard to see. 1, 2, 3, 3, 7. Oops. Yeah. So you have to change which one you do to get it to switch between 0 and 1, whereas this one, if I understand correctly, which I did just copy it from the robot to be fair, and I clearly don't have much of a grasp on bitwise math, so it's possible that I don't understand it correctly, but if I understand correctly, this one will let me always put either a 0 or a 1 in. I've hard-coded it to a 1 right now, but eventually what we would do is we'd have the same logic right here, and it would be hard-coded to a 0, and I would love to have the actual passage of code be the same. Maybe put it in a function. Yeah. I think ultimately either can work, but this one leads us to if we wanted to functionize it more like how I did ask the robot initially. This one makes it so the code can be the same, I think. We do like we could hard code it to the buffer, really. Shift. In fact, what I'm going to say is shift RW command it into, call it the address, correct or not. And then this can be hard coded to 0 because we always want the first byte in our buffer that we're writing, and then the thing here will be bit value. Then here it will be self shift 1. Here Okay. It did get the chip ID successfully. I think that was our issue, so now we just turn the rest of the stuff back on and see if the rest of everything just works, or if we have more to fix. Next thing it's complaining about is effectively that all of these are commented out. VM has an error. Okay. Right there still. I should make sure the function does behave affecting them. Do that actually. Let's print those values. It's doing it both ways. Or 0 is still 1. So not working. In fact, we should do this after we shift. Is super important, I don't think, for the specific issue at hand, but okay. So we definitely had a 0 in for the set because there's only 6 bits here. Those are presumably the register for oh. Uh-oh. Is it getting rid of the last one? Yeah, we might be pushing out the last bit. Okay. Just do, I guess, how we... So that would... If bit value is 1... I'm gonna... It doesn't matter. Only seeing those... and then I... Which one was for which? So when we were setting it to 1, that was the OR. So for 0, bitwise OR. And this one was bitwise 7-1. Still got chip ID was incorrect. Backwards? Gonna lose the... Okay. Yeah. That part was... It. But did we not just buffer? Currently, the most significant bit is 0. I set it to 1, so we go buffer or 3, 4. Worked. Buffer. Or they backwards? Was a 1. Changed it back to a 0 by doing this. Why is that not working anymore? Well, okay, we don't care so much. So we have to know what the bit currently is, right? We're checking the wrong thing. This is checking, well, you need to know both, basically. It means the logic in here is gnarly. Can I have one of these that doesn't shift out the lowest significant bit? To get rid of the LS, call it least. You rewrite it, serve all bits except for so to be clear, do that first. Oh, you need to do both. Gotcha. That's where this link. Well, we should still maybe raise. That one looks. So the set buffer should be 0. Or wait, 1, 2. Okay, it is 0 because there's only 7 bits. I wish I could pad that to 8, which I know I can, but it would add even more to that print statement. Here we're getting this again. got this value. I wonder if we could. Correct. Okay. So this came from when we called chip ID here. That printed this first, which is correct. We've shifted 1, which is the read value, into the most significant bit for the address, the register address 0, which is chip ID. We got back decimal 50, which is fine. Then we checked here. And presumably ended up with a different number. I wonder if we read it too fast again or something. Maybe, I think there's like a wait period or something. Maybe the fact that it's... I don't even know. I don't understand, because it was working. If this was in here, is it any different? But it's not changing fundamentally. We'd still be accessing it twice within quick succession. I guess we could sleep a little bit. It's not returning. You know it's printed it. And these... Maybe the fact that they're consts. Maybe the types are wrong here. That's gotta be it. That's my best guess. But I swear it just worked a minute ago. Like when we had, it turned out our function was wrong for other reasons, but we made it past this point, and I haven't changed this code. How did we make it past this point? Let's do type of chip ID and type of this. We happen to know is the one that we are gonna find. Those are both ints. But why would that be false? That's so weird. Oh. Wait. We have a... Okay. I wonder if we wrecked this now. Because we also then read into buffer... Right. But I am caught up on we have a hex value and we're looking for a decimal value, but I'm unclear on why they're different and why it worked a minute ago, a few minutes ago at this point. But also I gotta run to the fast, so I will BRB. Well, I mean, I know at this point I know it's not in there because we have decimal 50, but we're looking for decimal 80. But I totally can print them out. Are decimal 50 and decimal 80 1 bit apart when they're in binary? So it is false, but it's false because we have 50 and we're asking if it's in 80 and 81. But why do we have 50? Are 50 80? Yeah, they're different. Yeah, that's true. 0x hex 50 is decimal 80. But we are ending up with decimal 50 when we read now. Sometimes. Okay. How about, let's check this. So we are accessing buffer I. Is I ever 0? Because if it is, then we would be accessing self.buffer0, and maybe the fact that we changed it wrecked it. Maybe we need to immediately change it back after we do this. I'm still unclear on how it worked before. Maybe the fact that we pushed off one of the bits somehow made it actually work instead of not work. Can't tell it's not printing in hex. Which one? I can print any of them in hex. Not sure which one you mean. Yeah. Are any of these ever I? I mean, is I ever 0? Correct. That's true. Yeah. So I think that everything except the 0 index gets overwritten. I'm not 100% positive, but I'm pretty sure the fact that this is on start 1. So we're closer. We got values out instead of like all ones. The leading bit was the core problem. And it even worked for a minute. Oh, we can't see any functions. Can't I see any function? The whole buffer after it, when it prints 50, I think it's X. I think it's just. So this one would be decimal because I'm not calling hex or. And because chip ID is an RO bits, which basically pretend to be an int, decimal. It's chip ID decimal 50. Print the whole buffer after it returns. Buffer. Changing. B6 is what? Nothing in buffer changed though. Maybe we don't wait long enough? But it worked before, which I keep coming back to. Like, how did it work a few minutes ago? I get that part. And before and after. But it's also... So, I... Maybe we shouldn't... Maybe we can't be writing both bytes. We have 2 bytes. And we're writing them both. Maybe not. Well, yeah, I really need to see the docs for bus device. We writing them both? To the same place. The same place. It still doesn't have anything for the write function. I mean, are they the same as this? End. Text to start. Duplicate. Weird. Well, I guess I didn't duplicate. I clicked it into it. So, but not include. Yeah. So we're writing bytes 0 and 1. Maybe we shouldn't. I still don't know why it would have worked before. That part is still a mystery to me. Maybe we only had zeros before because I took out the other chip ID that came before reset. I think. But at this point, I don't even know where that came from. Structure. Called reset. But we can see here, though, before it was definitely 0, and after it is definitely 50. So that first chip ID is where the second byte gets set to 50. The only thing I can think of is when we go to write buffer here, we're writing 2 bytes, and maybe we shouldn't be, because so this has different ways. So SPI write can be single byte or burst write by read can be single read or multi-byte read. But in both cases, it's expecting only the address 7 bytes and the read command. There is also this, though, where it's a hybrid, but that's a write and then a read. Are the constants correct? Yeah, the constants are correct. I'm 100% sure the constants are correct because they're the same in the I2C driver. And they work as expected there. So these are definitely correct, and the exact same check exists here in the I2C driver, and the I2C driver works successfully if we just were to swap those to these. This, although I don't know if I made it to my didn't. Okay, I'm gonna change it back for now. Okay, well it's not connected over not connected over I2C right now. That's not gonna work unless I change the wiring. But I'm confident the constants are correct because they're the same in the other driver. Work. Let's try writing only the first byte. We only have a few minutes left. I'm still super perplexed by why it worked just once a while ago, but so end one would mean that because it said it was non-exclusive, non-inclusive, so it goes up to that. Well, assuming the I2C one is the same, then end is not include. Okay, now we're back. Now we're back. So I guess for whatever reason, before, I don't know, we had a different second byte. Maybe it's undetermined. Like maybe like if you do that, maybe it responds in an unexpected, undetermined way. But now we seem to be better. We are just back to NVM has an error, and I did uncomment all these things already, so we do. It is odd. Okay, so these 3 prints are here. Those are those 3. And then exception was raised from 289, which is here. Oh, you know what? This is a RO bit. Okay, I was like, why did we not get any more prints? But that's because this is a RO bit singular, not a RO bits plural. And there's probably the same problem for that, actually. Well, in fact, not only is there the same problem here, there's the same problem with getting that most significant bit. We need to do the whole writing the most significant bit thing. Okay, we are basically at time, though. But the good news is I think we have figured it out. The most significant bit needs to be done for this device. It may not be a standard in SPI, but if we want this library to be useful, we need to support it, probably with reverse polarity as well. For me on this device, it is 1 for reading, 0 for writing. But that could be different. We saw Jerry said it's different on the RFM, so we would want like a polarity thing. I wonder if we couldn't make... Oh no, because it needs to be a Boolean instead of a I was gonna say, couldn't RW bit just be an RW bits, but its length is set to 1? Maybe there's some efficiency gain. Anyway, I think once we do the same fix here, probably we are going to be good to go. The fact that we got the chip ID and figured out why it was wrong for a while, the fact that it was wrong with the hex of the decimal value made that super confusing, but we did get there in the end, and I think probably the rest of this will work if we fix RW bit. But that's time for tonight, so I will bid you farewell for now. I will be back tomorrow morning over on my own stream, over on my own channel, I should say, on YouTube and Twitch. If you are interested in some more CircuitPython content, development work, then I would encourage you to check that out. That's at 10 a.m. Central Time, usually, on Saturdays. And I try to remember to put links in the live broadcast chat, the Discord that's right here, when I get started. So you can check there if you want the links. Otherwise, I will say good night, farewell, thank you. In the chat there, thanks to Brian at Lindahl Engineering. Appreciate the help and bouncing ideas off back and forth over in the chat. Thank you to everyone else who was here in the chat, and also thanks to anyone who just watched and was not in the chat. That's totally cool too. I'll be back tomorrow for the morning stream. I should be back next week also for the deep dive at the usual time. 2 p.m. Pacific, 5 p.m. Eastern, 4 p.m. Central on Fridays, deep dive. Yeah, that's what this has been, the deep dive. I will bid you farewell. Thanks.